So we know about potential. We know that the electric potential is going to be the electrical potential energy per charge. So that means we could work backwards, and so potential energy is going to be Q times V. Now, how does that apply? Well, let's imagine that we have a charge, Q1, and I have some other Q2, and it's off at infinity. And I want to bring Q2 in and set it right here, a distance of R2 away from Q1. And I want to know how much energy does it take to do that. Well, from what I just said, the energy is going to be QV. So that means it would be Q2 times the V due to Q1. And so that would be KQ1 over R2. So that would be KQ1, Q2 over R2. Suppose that I have Q1 and Q2, and they're some distance R1 away, and I have some other Q3. And I want to bring Q3 and set it right here so it's a distance of R13, so the distance, the R between 1 and 3, and then R23. Okay, and so I want to put it right there, and I want to know how much energy is that. Well, that energy is going to be equal to Q3 times the voltage that exists due to Q1 and Q2. Well, that means it's going to be Q3 times K Q1 over R13 plus K Q2 over R23. So in other words, the energy would be equal to K Q1 Q3 over R13 plus Q2 Q3 over R23. Okay, so that's the energy that it took to bring that charge in. But what's the total energy in that system? So what would be the total energy in that system? So that's R13, that's R23, I call that R1, that's Q1, Q2, Q3. What's the total energy? Well, the total energy would have been the first energy plus the next energy. So the total energy would be equal to K times Q1, Q2 over R1 plus Q2, Q3 over R23 plus Q1, Q3 over R13. Okay, now suppose I brought a fourth charge in. So we have Q1, Q2, Q3, Q4. And I want to know how much total energy does it take to build up that system. Well, it's going to be basically the same thing. We've got the energy between these two, energy between those, there, every possible combination. So the total energy to assemble that would be equal to the K times the Q1, Q2 over R12, that's going to be the distance there, plus Q2, Q3 over R23, plus Q1, Q3 over R13, plus Q1, Q4 over R14, plus Q3, Q4 over R34, plus Q2, Q4 over R24. Okay, so we have multiple different sort of possibilities. So that means it's even more energy. Each one you put in is going to be more energy being put in. And so that means the energy rapidly builds up. It also means the first one that comes out is going to have more energy than the next one, has more energy than the next one. So if I have a system with a whole bunch of charges in it, the first charges that come out have more energy than the next charges that come out. So each one is harder to put charge in, and that makes it build up much more quickly, the total amount of energy stored. And so we'll get back to that when we talk about capacitors, which are energy storage systems.